This conference will
elastic
now be
load,
recorded.
right? Elastic load balancers. Very important concept here about the AWS environment. Typically, this is going to be enabled for us in the real-time environment. So what does load balancer will do, and how many types of algorithm it's going to be used? Okay, give me a second. Now, so how many types of load balancers are there, and how does it going to be helpful? Elastic load balancer are typically going to be helpful to enable the high availability for your respective setup. So how the routing is going to be happen here in your respective real-time environment? Here you have an elastic load balancer, right? Here you have an elastic load balancer, and here you going to be having your respective EC2 instances in at least two availability zones, at least either in 1A or in the respective 1B region, or in the respective 1B region, right? Either in the 1A or the 1B region here. So typically, one availability zone is went down, it's going to be route the respective request to the second availability zone. Right? It's going to be route the request to the second availability zone. Typically, if one availability zone is went down, it's going to be route to the second availability zone. The request is going to be route to the second availability zone. Right? This is how it's going to be happen. So there are two availability zones here, or two or more availability zones. These elastic load balancer will going to be receive the hits from the respective end user, right? And it going to be route that respective request to the right, route the respective request to the this availability zones here, right? These availability zones. So this is how it's going to be happen, right? This is how it's going to be happen here. So now here, so now here, so now here, we'll try to enable the respective elastic load balance. This elastic load balancer has been classified into three types. This elastic load balancer has been classified in this elastic load balancer has been classified into three types. One is with the classic load balancer, that one is with the classic load balancer, and the second one is with right, and the second one is with application load balancer. Second one is with application load balancer, and third one is with the network load balancer. Third one is with network load balancer. Third one is with the network load balancer. These are the three load balancers which are there in the respective ELB. One is classic load balancer, and second one is the application load balancer, and third one is the network load balancer. Now here in this generation, you got and one more load balancer called gateway load balancer. Actually, we're also going to be discuss what is the gateway load balancer here as well. This is the new 2020 they have introduced the gateway load balancer here. So classic applications and network in the respective gateway load balancer here. Right. So this is how it's going to be happen. Right. This is how it's going to be happen here, the gateway load balancer. So now here, these are the things that you guys need to understand. So what is elastic load balancer? This is going to be the end user perspective, right? This is going to be receive the traffic and it's going to be distribute the traffic to the register resources, right? Register EC2 instances, right? The ELB will distribute the traffic, right? Will distribute the traffic to its register resources, to its register EC2 instances, to its register EC2 instances, right? To its register EC2 instances. The ELB algorithm, the elastic load balancer algorithm, is of two types, right? Is of two types. The first one is with, right? The first one is with round robin algorithm, right? Round robin algorithm here. The second one is with least count based algorithm here, right? Least count based algorithm here. These are the two things, right? These are the two things here. One is round robin algorithm and second one is least count based algorithm. So now here, what is the meaning of round robin here? Now here, what is the meaning of round robin here? What does it do? One after other. Thanks, you spoke something.
Yeah, basically it will route the traffic, based on sequence. If it is there is a two host, it will send first traffic to first host and second traffic to second host, and it keep on round robin.
Yes, yes. Thanks, Sasi. Right, thanks. So now here, the round robin algorithm here, how does it going to happen? Here you have an ELB. As Sisi said, if suppose there are 10 hits, suppose there are two instances in the two availability zones. The two availability zones. This is on 1A availability zone, this is on 1B availability zones. The first 100 hits, let's consider you have an 100 hits here. These 100 hits, it will first transfer to the 1, 2, 3, 4, like that, so on. 5, 6, 7, and 8. Up to 9, 10, 11, like that. It keeps on going to be sent one after other, right? One after other respective EC2 instances, one after other respective EC2 instances. That's how it's going to be happen, right? Whereas least count based algorithm, right? Least count based. For example, the least count based here, right? Least count based algorithm here. For example, here you have an, let's say suppose the least count. Here you have an ELB. Here you have an respective EC2 instances. Here you have an respective EC2 instance. Here you have an respective EC2 instances. Right here you have an respective EC2 instances. So now here, let's say suppose these are register from the time of creation of EC2 instances, from the time of creation of ELB. These two instances got registered. This is 1A and this is 1B. Two instances got registered. This is 1A and this is 1B. The next instances which is registered in recently, let's consider this is auto scale instances. This is auto scale instances. Now this is registered with, this is received almost 200, right? 200 hits, and this is registered almost with 300 hits. This registered almost with 300 hits. So now here this is registered with recently and received the 100 hits. Which is the least count here? 200 or 300 or 100? Which is the least one here? Which is the least one here? The 100 one, right? So this is the least one here. So it will try to send huge number of hits to this respective least one, right? It try to send the huge number of hits to this respective least one here. That's how it's going to be work. Clear? What is the main difference between, right? What is the main difference between the the least count and the respective, the least count and the respective
round robin
algorithm. Any questions, any doubts here? Right? So this is how it's going to be work. So now here in this elastic load balancer, what is your whether as per your understanding, which is the best suitable one? Least count or the round robin?
round robin
Round robin.
Least count.
How many of you are least count?
It's both, I guess, based on the scenario.
Mm, no, round robin is best as per matter. Why? Because it's sharing the load across all the the servers. So it is goes to least one, right? So the load will be unequal. So it will be like that way the round robin is good.
But the right approach is least count actually. Why? Because if I attach the new instances, right? If I attach the new instances, so it will automatically, these new instances will have an energy to receive it, isn't it? The newer one, the Engcham one, will going to be receive the more number of hits. These are the older ones, right? They already received. There might be an high CPU, right? Because of that, I have increased the respective instances. If I put the respective least count as my respective algorithm of the load balancer, the newly registered instances will going to be receive the high traffic, and they can serve better when compared to these two. Clear? So least count is the right one actually to choosing of your respective field. So now here I'm going to create a two instances here, and I'm going to give an example for the classic load balancer. The classic load balancer is a previous one actually. So previous generation load balancer which does not have any kind of embellishments. There is no features for the classic load balancer. It simply route the traffic to the register EC2 instances. So classic elastic load balancer, right? So load balancer is going to be distribute the traffic to the register resources, right? Load balancer will going to be distribute the traffic to the register resources, whereas classic load balancer will going to be distribute the traffic without any additional features of your, like the way of your respective application load balancers and network load balancer. Now the classic load balancer is a previous generation load balancer here. Call this one as a previous generation load balancer. It simply route the traffic to the registered instances, right? previous generation load balancer. So it will simply route the traffic to the register instances. So this is one main important thing here. So now here I'm going to create a two EC2 instances. Here I'm going to create a two EC2 instances here. So now here two instances I'm going to do. Yeah, that I will explain now. One, how the ELB is going to perform the health checks to and register instances. Those things I will perform, right? So now here I'm going to be selecting the two instances which is on 1A and second one is on 1B, right? Which is on 1A and second one is on 1B. So now here you have two instances. So I'm going to be enable and bootstrapping here. So two instances, one thing I'm going to be created on 1A and the second thing I'm going to create on 1B. So here you have an Amazon Linux 2 and T2 micro. Here in that respective bootstrapping, we're going to be pasting a simple shell script, and here we're going to be have an AZ1A, right? AZ1A. Here I'm selecting the respective resources as AZ1A. Right, AZ1A. Here I'm selecting the resources as AZ1A. So 15 GB is the respective storage environment. The tags here I'm going to be provide the name as 1A. So I would like to go this one as an AZ1A. So which port I need to open here for Apache? What is the port number I need to open here for Apache?
80.
80, right? 80 port I need to open. So now here let's open the port 80 and review and launch the instances. So create a new key. So dev hyphen so Singapore, download the respective key file and launch the instance. Right. Similarly, let's create its second instances on 1B region. Let's go with the Amazon Linux 2 here. T2 micro. This is going to be, this is an example for AZ1B. So here select the availability zone here as 1B. Let's add the tag gate, and here it's going to be in 15 GB. Name equal to AZ1B. So here HTTP, here 80. Review and launch. So these are the two availability zones, right? You have created the two availability zones. Two instances we got created. So now here we're going to be enable the respective, right, two agent here on two different IP address here. So one is on 1A and second one is on 1B. So AZ1A and AZ1B. Right, AZ1A and AZ1B. So now here, as per our approach, what you guys are going to do, you guys are going to be create a elastic load balancer here, which is on 1A and this is on 1B. Right. This is on 1A and this is on 1B. This is on 1A and this is on 1B. So this is one thing that you guys need to enable here. This is on one thing that you guys need to enable here. So now here, you guys are enabling the respective, right? You guys are enabling the respective elastic load balancer. So go for the elastic load balancer here. Create a load balancer. So here you have an classic load balancer, which is a previous generation load balancer. Then this supports HTTP, HTTPS, TCP, and SSL. That means TLS actually, right? TCP and TLS actually. TCP and TLS actually. That is one main important thing. TCP and TLS. That is one main important thing. So HTTP, HTTPS, and TCP and SSL here. TCP and SSL here. So these are the protocols it's going to be supported. Right? These are the protocols it's going to be supported here. So now here, let's select this one, classic load balancer. But this is going, see, the disconnect. AWS will be returning the EC2 classic network on August 15th. So basically, this classic load balancer is not going to be helpful for in your respective production, right? Respective production actually. This classic load balancer is not going to be helpful for your respective, right, in the real-time environment. So that is one main important thing. So now here, let's create it. People will going to be use application load balancer actually. Most of the times you guys are going to be use applications or the gateway load balancer. Right? So now here you have an prod CLB, right? Prod CLB, right? Production CLB here. Here now you have an HTTP port 80 because as you don't have HTTPS SSL certificate, you don't have. You guys are going to be discussing that respective SSL certificate creations on our respective section called AWS Certification Manager. On AWS Certification Manager. so that you guys are going to be certificate manager, so that you guys are going to be enable the SSL certification, and you guys are going to be route your traffic to the HTTPS, route your traffic to the HTTPS. So these things will going to be discussed here: AWS Cert Manager, SSL, and HTTPS. So now here, you guys need to understand about the classic load balancer at this moment. So to know about the AWS certification manager and how to enable the SSL and how to enable the HTTPS traffic, before that you guys need to understand the concept called Route 53. So you have a time to learn these things. So firstly, we'll focus on creation of the load balancer with HTTP with no SSL certificate too, right, for your respective application load balancer. So this is prod CLB. So create a new one, and HTTP listens on port 80. You're enabling the port 80 here. HTTP listens on port 80. You're enabling the port 80 here, right? So this is one main important thing. So now here, so this is the main important task, the health checks. So now here you guys need to understand about the, right, now here you guys need to understand about the HTTP response code. HTTP response code. As a DevOps engineer or as a AWS engineer, you guys need to know about the HTTP response code. If HTTP code returns 200, it is called success code, right? This is called success code. If HTTP returns 301 or any error with related to 3 access, that means 300, 10, 15, whatever it is, 301. This is called redirection issues, right? Redirections issues. And if HTTP response code has written the 401, which is nothing but unauthorized, right? Which is nothing but unauthorized. And if suppose it is written on 403, so forbidden, actually forbidden error. And 404 not found, right? 404 not found. And all kind of 5-axis errors, internal server error, your application error, right? Your internal application server error actually. So basically this is your success code, and this redirection issue need to taken care by your developer. Unauthorized in the sense your username password as invalid, right? That your username password as invalid. And 403 is a forbidden actually. So that means you does not have the permissions, application does not have the permissions to access the file. And 404, the method not found actually. Right, 404, the method not found actually. So that means the content which you are looking for is not available, right? Content which you are looking for is not available in the respective application, right? So now here, and 5-axis internal server error. So this is one main important thing here, right? So these errors you guys need to remember as a DevOps engineer, and this will going to be through the application will going to be through the respective errors here, right? Application will going to throw the respective errors here, right? This you guys need to remember. So now here you guys need to understand the curl command actually. So to understand this respective health checks, someone asked me, I think Pawan asked me here. So before understanding the health checks, you guys need to understand the curl command. So now we're going to be we're going to be understand about the curl command. Any questions as of now would you like to ask me, guys? You guys are good? Any questions as of now? Any questions, guys?
Good. Good, good.
Yeah. So now here, let me convert .pm to .ppk. So I'd like to make this one as a Singapore. Okay, so now here, you guys going to be understanding about the curl command here. What does it do? That's not comes to in our scenario. Pawan, that is not the comes to our scenario. We're not discussing about the application URL routing actually. That is through API gateway. We're just discussing about only the application load balancer, how it works. The load balancer, how it works. The client URL, those things are going to be decided by your respective application gateway. So now here you have an curl command. So to check the running services in the Linux server, you need to use a command called netstat-ntlp. NTLP. To check the running services in the server, you need to use the command called netstat-ntlp. So now here, these many services are running by default. Now here, these many services are running by default. So now here, you are looking for HTTPD. That means Apache service is running on 80. Right? Apache service is running on 80 here. So this is one main important thing. So now here, when you guys are using the curl command, so curl is the main command that you guys are going to be used in your respective real-time environment. Curl-v HTTP localhost. So what is the code it has been written here? $200. That means the application is running fine. Right? Application is running fine. Basically, how this routing is going to be happen here. So if you observe that in our respective bootstrapping script, I use the command called echo and the respective print, and to this respective var www.html. var www.html slash index.html. var www.html slash index.html here. So now here, See, this is the where www HTML and index.html is called success code actually. Right? It's called success code actually. Where www HTML index.html is called success code. So now here this is called default document root. Right? This is called default document root. Right? This is called default document root. Right? And this is here you are having the index.html. When I'm using the curl, and HTTP localhost, that means I am trying to connect to my local host with a protocol called HTTP, which listens on 80 actually, right? Which listens on 80 actually, and it returns the 200, right? So where exactly this query has going to be executed? In the var www HTML, which is the default document root of Apache, right? Under that, it's going to be having a page called index.html. It's going to be have a page called index.html, and it's going to be enabled here, and it return the 200 code. Here the ping protocol is HTTP, the port is HTTP listens on 80, and the default document root is var www HTML, and where is the path you guys are using? Index.html. Clear about this step, what you guys are doing? So this is what it's going to be do for your respective health checks on the backend. The ping protocol is 80, sorry, ping protocol is HTTP, and the ping port is 80, and the ping part is index.html, right? Index.html. So this is what it's going to do on the backend, and it returns a port 200 as this, right? Response code actually. So now here you have a response time of 5 seconds. So which means the load balancer is trying to connect to the EC2 instances, and it is calling the respective EC2 instances. The response time here is having the 5 seconds here. It trying to call the register EC2 instances for 5 seconds. Right? It trying to call the register EC2 instances for 5 seconds here. Right? It trying to call the register EC2 instances for 5 seconds. The load balancer will call the EC2 instances for 5 seconds. It will wait for 5 seconds. If it got responded within the 5 seconds, right? If it got responded within the 5 seconds, it will wait for 30 seconds again. Right? It will wait for 30 seconds here. Again, it will call after 30 seconds. Again, it will call for 5 seconds. If these 2 iterations, it will return the 200 success code. Then it considered this EC2 instances as an healthy state actually. Then it's going to consider the EC2 instances as a healthy state. Am I clear on this? Any questions, any doubts? So this is how the health checks are going to be performed. Am I clear? Right? So now here it will wait for first 5 seconds, the response time, and again it will wait for 30 seconds. Again it's going to check for 5 seconds. If it is going to be returned 200 the success code, the application is going to be returned the 200 success code, right? This is going to be considered as an healthy instances. This is going to be considered as an healthy instances, right? So now here, if suppose it's going to be failed with this respective health checks, right? With this respective health checks, This will automatically consider the respective EC2 instances is in unhealthy status, right? Unhealthy status, and it will not going to be send the traffic to the unhealthy instances. Load balancer, elastic load balancer, perform the health checks, right? Perform the health checks. Load balancer, elastic load balancer, perform the health checks. If it notice the unhealthy health checks, unhealthy instances, unhealthy EC2 instances, right? If it notice the unhealthy EC2 instances, it will not send the traffic. It will not send the traffic to that unhealthy EC2 instances. It will not send the traffic to the unhealthy EC2 instances. It will only send the traffic to the healthy EC2 instances. Right? It will only send the traffic to the healthy EC2 instances. So now here you consider this one as a response timeout is in 5 seconds. That means the load balancer is calling the respective EC2 instances for 5 seconds. Right? Again, it will wait for 30 seconds of intervals. Unhealthy threshold is 2, and you can also enable the healthy threshold as 2. That means in 2 iterations, it got succeed and it got the response of 200 to its from its registered EC2 instances. Then it's going to consider as a healthy EC2 instances here. So now here I'm going to register these 2 instances here. Right, I'm going to register these 2 instances here. So tax prod LB, tax prod LB, environment, production, and review and create. So this will going to be generated DNS here. So now here this is the DNS is your respective entry point for your respective application. So this will take at least 4 minutes, 2 to 3 minutes to enable here. Am I clear on this? Any questions, any doubts, guys?
No.
Yeah, we'll wait for till this respective DNS propagation and till this respective health checks are going to be passed. We'll wait for it a couple of minutes. No, from the load balancer, you need to find out which instances got registered. From the load balancer, not from the instances. Or else you can directly go with this respective instances. You can find out which instances is connected to register to my respective load, elastic load balancer. From the load balancer, you need to figure it out. So this is one thing now.
One
So
more
now
question
if you
here.
look at, sorry.
Yeah, I have a question here. So once this load balancer is up, right? So can it send our request again to the instances, individual instances, if needed?
No, if you register the respective individual instances under the roof of elastic load balancer, then only it will send, or else it will not going to send.
So every request has to be routed through ELB now, right? Instead of
Every request is
direct.
routed to the ELB. Individual instances will not going to get the request.
Okay, got it.
Right. So now here, so this is one. So if you look at here, it transferring the traffic as 1A, 1B, 1A, 1B. It transferring the traffic to the 1A and 1B. So now here, in which algorithm it is working? In which algorithm it is working here?
Round robin.
Round robin.
Round robin algorithm here. So as I said earlier, in the classic load balancer, you don't have any. In the classic load balancer, you don't have any additional features. It will only perform the routing of your respective traffic with the help of round robin mechanism here. So now here, so now here, will going to be terminate one instances. We'll see whether this respective load balancer is automatically going to detect the faulty instances and make it as unhealthy. We'll see that. So go for the respective agent 1B, that go first instance state and terminate the instances. So this load balancer should automatically recognize the faulty in the instances. This load balancer is automatically right. This load balancer is automatically recognize the faulty instances, and it should going to be right. It should going to be terminate the instances. So now here, if you observe that this is automatically removed from the load balancer, it will not going to send the traffic to the faulty instances, right? It will not going to be send the traffic to the faulty instances. So that is one main important thing, right? This is not going to be send the respective traffic to the faulty instances. That is one main important thing. So now here, it will not going to be, it will only sending the traffic in the 1A availability zones. Even though 1B is going to went down completely, this is going to be enable the 1B availability zone. Like this is how it's going to be happening. So here the reason how the classic load balancer works, it routes the traffic to the different availability zones. It routes the traffic to the different availability zones here. Right? Different availability zones here. So now here, to avoid the limitations, to overcome the limitations of the classic load balancer, to enable the respective application performance over the respective load balancer, to make developer work easier, you guys are going to choosing the application load balancer in your respective real-time environment, right? Which only supports the traffic HTTP and HTTPS, will only support the traffic will HTTP and HTTPS. But here you have an other features like, right? Other features like here. Global accelerator and host based routing here and many more. So application load balancer, right? Application load balancer, right? Application load balancer will support the HTTP code from 200 to 399. From 200 to 399. From 200 to 399. Application load balancer will support from 200 to 399. 200 to 399 here. Application load balancer will support from 200 to 399 the successful. But whereas classic load balancer only supports the code of 200. Whenever your application is reacting only the 200, it will support. Right? This is one main important thing here. No, you cannot add. You cannot. So now here it will support the HTTP code of 200 to 399 here, and application load balancer will support only the HTTP and HTTPS protocol. So when I'm talking about HTTP and HTTPS protocol, so generally which ports are going to be helpful for us here? HTTP and HTTPS protocol, generally which ports are going to be helpful here?
80 and 443.
80 and 443, or probably if it is an Apache Tomcat 8080 or 8443. If it is a, generally you have an override port option. Override the port. So whatever the port, either you want to go with 31380 or 31390 in between the 0 to 65,535. Right, 0 to 65,535, you can use the port override option and you can enable it. That is one main important. Am I clear? That is one main important. So now here, application load balancer will support the HTTP code of 200 to 399 and with HTTP and HTTPS 8080 and 8443, and override the port of 31380 and 31390. Whatever the port you require in between the range of 0 to 65,535. So now here it will having the features like the features of ALB here. It will have the features like host-based routing, right? Path-based routing, right? Path-based routing, right? Source IP-based routing, and source IP-based routing. And one more thing here, you guys are going to be used header-based routing. Header-based routing, right? Header-based routing, right? Request method, HTTP method-based routing, right? HTTP method-based routing. These things will going to be enabled, right? These things will going to be enabled here, right? This thing will going to be enabled here. So in the future, and it will have an one more, right? One more strategy called target group. Right? It will have an target groups. Application load balancer as well as network load balancer will going to have a target groups actually. So now here, what is target group? What is how these features are going to be enabled? What is the host based routing? What is the path based routing? And what is the source based routing here? So all these things will going to be cleanly discussed in our tomorrow section, right? So any questions on the today's one here?
Shanmugh, can you explain the third point, override of the port?
Yeah, so someone asked me what ports it's going to be used actually. See, for example, my application is listening on 31380. It's not listening on the default port or 80 or 443 or 8080 or 8443. It has been listening on the customized port. For example, my application is listening on 31380 or 31390. So by using the port override option, I can use that respective one, right? So that's how the port override option is going to be there. So I got your assignment, guys. So thanks for that. Pramod got submitted. So I will verify. So and I will post my comments in the group. Right.
Okay.
And tomorrow we'll start at 8 actually. So any questions you'd like to ask me? Okay, what is persistent request in the spot instances? What does it do? Wait,
So it
till I
will.
have not entered the class. People are leaving. Yeah, what does it do? The persistent request actually.
Persistent means is a permanent disk. So whenever the instance goes down, so the data should be available in the EBS volume.
No, when
Okay,
the
here the means the maximum of $2. What does it indicates actually? What does do after $2?
we quoted the price of maximum $2.
Yeah, what does it do?
So if it reaches that, instance will go terminate.
No, we are quoting the price. We'll get the maximum price for $2.
After that, what does it do? If it reaches $2,
It will not assign it for us.
No, it will stop. It will. No, it will stop, right?
it will stop the instances actually.
Yeah.
As soon as it got reached this one.
Yeah.
Have you tried how to delete the spot request actually? How to terminate the instance?
I deleted it by just giving the actions tab and terminate the instance.
Here in the spot
Yes.
request, when you're writing a spot request, here you need to terminate the instances. As soon as
Yes.
you have cancel your spot request, then only your instances are going to terminate here. But here you have choose the Red Hat actually. So most of the time you need to choose the Amazon Linux. In the real time, they will use either Amazon or either this thing.
Actually, I'm a Bhaskar sir student. When attending the DevOps class, I choose Red Hat.
But in real time, they used to go with Amazon Linux, not with the Red Hat.
Okay.
If you are using the Red Hat, so what is complication here is, so here they will going to be right here they will going to be charges for your respective upgradations actually. When if you want to upgrade any kind of package, you need to put a license there.
Okay.
Which instance is used mostly in real time? AWS only or
No, Amazon Linux.
Amazon image only?
Amazon Linux.
Okay.
Okay. Up to this is fine. So yeah. So I will check this one. So rest of the people as well, right? And I will post you the comments if I find any, or it's going to be okay for me. Right? So Pramod one is
Most
okay.
common interview
Sorry?
question. What is load balancer? And no. Load balancer is the most common interview question.
What is load balancer? What does it do?
Yeah. What is host path and
Yeah, that is the key point actually. That is the key point for your respective application load balancer. I will discuss.
I have shared that my AMI to your account ID. Just cross check once it's available.
You say to my account.
Yeah, because yesterday I was watching videos, so I saw your account number, so I shared it.
Which region you did?
Mumbai.
But AWS wise is very interesting, guys. If you learn the AWS, Azure is nothing actually. You can fatapat within 3 days you will complete the Azure syllabus if you learn AWS thoroughly. Because same concept actually, so exact Xerox copy. This is the one,
Yeah,
first AMI.
yes. Yes.
Fine, I got it. Right. So now here, yeah, that's all from today. So now here, this is a simple test actually. This is out of AWS, but still you guys need to go with. Don't consider this one as an assignment number 2. So create a EC2 instances with Apache Tomcat by using the user data. With user data. That means you need to write a script which is going to be regards to the, right? You need to write a script which is going to be regards to the Apache Tomcat. As soon as you have going to be enable the EC2 instances, as soon as you have did it successfully, you need to listen that respective, you need to open the security group. Which port you guys need to open in the security group if you are using the Apache Tomcat?
8080.
You need to open port 8080, right? So now here you guys need to enable the respective 8080 port, and you need to use the public IP :8080 to check the output. For example, if your public IP is 13, 140, 115, and 80, this is :8080. So this is what you guys need to showcase, right? Probably this is going to be really helpful for you. Apache Tomcat also they will use in the real time, right? This one thing you need to.
Mukshu, I have tried with the Nginx actually. It works. I use Ubuntu image. I just tried with the Nginx. It works actually. I just tried with
Nginx
the
also,
Nginx.
yeah, you guys need to know about Nginx as well. What does Nginx do? How it's going to be helpful for you?
Yeah, we already you tried HTTP, right? So just I tried with Nginx.
Yeah, instead of the HTTP, you need to put Nginx. That's it. So that's good. But this one Apache Tomcat also you guys need to enable, right, by using the user data.
Yeah, sure, we'll try it. Yeah.
Right. So thank you guys. That's all for today. We'll connect by tomorrow.
Okay, thank you.